Okay, so we just wrapped up week 1, and we are going to dive into week 2. All right, so let's just take a peek through week 2. I'm not going to read through all this, but the point is there's P, there's F, and there's A. And the classic problem in economics is, would you rather have $1 today or would you rather have $1 tomorrow? And the answer is, I'd rather have $1 today. And the next question is, well, would you rather have $1 today or $2 tomorrow? Et cetera, et cetera. So that's sort of the P versus the F. Present value of money versus future value of money. Or another example would be, would you rather have $7 today or $7 a week from now? And the answer is usually, I'd much rather have the $7 a day. Or let's try it this way. How about $1 a day for the next 7 days? Now, some people might say, that sounds better because that way I've only got $1 at any given time, and that's the most I can lose. You know, maybe I'm going to get mugged or whatever, or gosh, I don't trust myself, so yeah, just give me that $1 a day, and that's the most I can lose. So you're not really as big of a risk. But the basic way that money works, though, is if I'm going to go to the bank and ask for $100 now, they're going to want more than $100 back later, and they're actually going to, because the banks themselves are actually borrowing money, because the local bank is probably going to owe the bigger bank money at some rate that's sort of climbing up. And let's say Missoula Federal Credit Union borrows $1 million from the Fed, for example. Not that would happen, but the Missoula Credit Union might have to be paying that back at 2% or something. So they're going to have to always stay ahead of that and ask you, the consumer, for 4%. And then the big question is, well, where do those extra $2 or $3 or $4 come from? Well, they kind of come from everywhere, which is a little strange, but yeah. But that's really what we're looking at, is the present value, future value, or the annuity value, what it costs as we move through it. So when we're going through our economics, you're going to have to say, hey, it's going to cost me something up front to get the thing in. The gas turbine is going to cost something to build it, but also sort of an annuity for fuel, and then maybe operation and maintenance, and then labor to run this thing. Then at some point there will be a resale value or a salvage value as well. Current transducer, that's fine. There are some neat movies out there. I won't burn lecture time on it. Here's, again, computer hint. Oh, and if you haven't discovered this, I do highly recommend the Alt-Tab. That's what I'm doing right here. Using Alt-Tab to get between these. So if I want to get quickly between that and that, I can Alt-Tab it. Resize, do Control and scroll. You might not necessarily have the scroll wheel. I don't have that currently on my laptop, but I usually use Control minus or Control Shift plus for these windows. I don't have a wheel here, so, but there's minus, there's plus. So what we're going to do today, here's assignment. Yeah. So again, there are only three values: the present value, future value, or annual value. You're going to have a number of terms. The thing I just used was 7 days. And we'll also have a discount rate. And what I used there was the interest rate, which is 2% or 4%. So those are really the only numbers that we'll have to do. And since there are three separate values, present, future, and annuity, there are 6 different ways to combine them. And we're looking at all 6 right here. 7% discount rate for 10 years and $10,000. Okay, so this is problem 1. And let's just go ahead and, so again, on the forum, if you're having trouble with problem 1, let's just start problem 1 thread. And then the same thing, there's problem 2. There's 6 problems total. So, we'll have a maximum of 6 threads. So let's just go ahead and do problem 1. And I would like to just, walk you all the way through this. So let's see if I can find it here. Okay, so here we are. I've just called this tab equivalence factors. And what I've done here is I've broken these out by problem 1, 2, 3, 4, 5, and 6. And so for equivalence factors, what you are first going to have to do is to build the formulae. And if we go back, let's see, from here, 10 years, $10,000 and 7%. I'm just going to jump right out and put 0.07 in there. And some numbers are coming out. And I think was it 10,000? Yeah, 10,000 and 10 years. 10,000. Okay, now that you've seen the answers, let's figure out how to get there. And hopefully you can read this guy okay. But so what I've done, this first one is finding the present value if we know the future value. And I think last time we found that Wikipedia was actually a pretty good resource for this. So
Time value of money.
Thank you. I think the formulas were in a nice little table at the bottom, weren't they?
That's what I used.
Yeah. Yeah. Okay. So if we're given the present value, we want to find the future value, the formula is the future value equals the present value times 1 plus the discount rate to the nth power. So let's see if that's what we have in here. And we're going to say that whatever cell in here is the number we're starting with. So the present value, which is 10%, times 1 plus the discount rate to the 10th power. Now I've got it as the negative 10th.
It's because of the formula for it.
Yeah, let's go back here. Okay, so let me, give me a quick second. Because there are different, there's different ways to write this. There's sort of a forward way and a backward way. Let me make sure I've got the one we were looking at. So actually I got ahead of myself just a little bit. So let's start here. And I want to show you and I wish it were written like this. F of P. I mean, that's typically how it's written in algebra or as a function, but the accountants just, I don't know if they're lazy or what, but they'll write they'll write it like this. So the question is, given the present value, and again, I'll click here, if we can see that the present value is in B6, that's 10,000, times 1 plus the interest rate, or the discount rate, which is in B4, 7%, to the 10th power. So you notice that in this case, the power is positive, as it should be, and the number goes up. So if I put $10,000 in the bank today for 10 years at 7%, in 10 years I will have $19,671. And that is this formula right here. So that is F/P, or F of P. The one I was looking at a second ago was the present value given the future value. And that's where that negative comes in. Was that your question, Shauna? Okay. So, yeah. So let's just do it this way. So we know that.
I have the same answer you did, so.
Yeah, I'm trying to think of a simpler analogy. So if I do, I think if I do equals 4, I think you can use the caret. Yeah. So what I put in there was just 4 squared.
Okay.
I put in 4 squared, so equals 4 to the second power. If I go here, equals 4 to the negative, or no, to the power -2. Let's see. I thought I was gonna, let's see, 1/4. Let me see. Negative. Give me a second to play around with this. Okay, so here's a simple example. What I've done here is I've typed in equals 4 squared, which is 16. And what I've done here is typed in equals 4 to the -1, which is 1/4. So it's 4 to the -1 power, and that gives me 1/4 as I would expect. Another way to write it would just be to say equals power, open paren, 4, comma, -1, same answer. Yeah. So 4 to the -1 power is 1/4. Okay. All right. So we've got that one. We've got this one. And this, what in words, what this says is that if I want to have $10,000 in 10 years into the future at 7% interest rate, I need $5,083.49 in the bank now. Okay. Now the other ones get a little more complicated, but it's just math. So if we're looking for the present value, or P as a function of A, this is going to be let's just go to our next one on our spreadsheet. So if we're given A, and we want to find P, yeah, that's kind of the gnarly one. We're given A, we want to find P. So given A, we want to find P. In the numerator, well, out in front, we've just got the annuity. And then the numerator is 1 plus I to the n minus 1 divided by I times 1 plus I to the n. So that's that guy. Let me see if I can get these on the same sheet at the same time. So our eyeballs can shift back and forth. Okay, so what I'm trying to compare right now is what's in this cell with what's down here. So again, V6 is our annuity. times, here's what's up top, which is power 1 plus B4, which is our
Right.
rate, thank you, to the 10th power, that's when it's in B5, minus 1. So this whole thing right here is the numerator. And then I'm going to divide it. Here's where that double division comes into play. So I'm going to divide it by B4, which is the rate. And then I'm going to divide it by 1 plus the rate to the nth power. So this says that I can either have $70,000 now, or I can have
1,423,
or I can have $10,000 every year. Now that might seem kind of weird because you might say, well, gosh, if you gave me $10,000 a year for 10 years, wouldn't that be the same as $100,000 now? Well, no, you don't need it, because if you took that $70,000 now and invested it, it would be the same as having $10,000 a year every year, because you're invested it. So the money actually gets bigger over time. Yeah. 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 Okay, so here's the annuity over the present. So I can either have $10,000 now, or I can have $1,400 a year for 10 years. It's the same question. Which would you rather have? Well, same difference. If it's 7%. If this goes down, let's just say it's 0.01.
That's crazy.
1%. Let's say it's, 0.000001. Well, it's like, why bother? It's same difference, like having no interest at all. That's when this whole thing kind of, flattens out, if you will. So 0.07. All right, and then the future to the annuity, and again, I'm not going to beleaguer each one of these. The formulas are all right here, time value of money. But in words, this is saying I can either have $10,000 a year for 10 years, which would be 100,000, or I can wait 10 years and just get 138,000 all at once in 10 years. Take your pick. How long can you hold your financial breath? Okay. And then this one is, do you want $10,000 in, do you want $10,000 in 10 years, or do you want 723 every year for 10? So let's go back to the problem statement. Six separate equations, done that. 7%, 10%, do not hardwire them. I may change my mind. I want you to calculate 3.5, which we can do. Let's just see. 0.035. And we're all done. Excel calculates a lot faster than we do.
Yeah, my fingers can't.
So, okay, well, that's problem one. Now, as suggested, if you decide to reuse problem one and the other problems, copy what you need and edit as needed, so the problems are solved independently. So that's why I said, get these tabs going. So I can, what we're saying here is I can just take this whole thing, I'm just going to grab it, copy it, paste it, and there it is. It's just, it's just doing the same old thing over and over again. 0.1.
So do we have to have the F over or P over F and all of that for each problem?
Well, let's take a look.
Because it's not asking that.
So problem 2, how much money should you put in a savings account now to have 10,000 5 years from now? Well, so the first thing to do, I would just take this whole thing and, yeah. How much money should you put in savings now? Have 10,000 in the account 5 years from now. Yes, we're putting in, so F goes in, and yeah, so we know F, we know the future value. So we're using the P as a function of F. And yeah, it was just basically that very first formula. We changed the 10 years to 5 years, changed the 7% to 10%. And if you haven't done so yet, you can come in here and do a control 1. And there's percentage.
I find you funny doing it that way.
Oh, you don't like that? I think they're all up here too,
It's
right?
in your home tab.
Okay. Well, that's why they make it that way. Back in the bad old days, there were no mice. There were no, I mean, yeah, there were keyboards. No touch screen. Where did you say it's in home now?
Yeah, right there in the.
Oh, you can click it on percent. Yeah, okay. Put the commas in or not.
Change your decimal places.
Nice. Cool.
Computer model.
There we go. Nice. Gotcha. There's another thing in here I kind of like. I don't know if you'll find this. Oh, I guess it's all right here. Text. More number formats. Here's one down. There's one in custom that I just found recently. It's it puts the $ over here.
Oh, hey,
Makes it a little cleaner to read.
yeah.
You just kind of focus on the number, like, okay, fine, it's $1, but if it's always right justified, that $ kind of moves around. Oh, what is it, a 5? Is it an S? Well, it just goes over there. So that's one I just learned recently. It's kind of cool. Yeah, I like it too. I like it too. Yeah. Problem 3. Okay, so this is what something's going to be worth in the future, 15 years in the future. So this asks what the annuity is. So you might say, hey, PV guy, I'm going to want your panels from you in 15 years. I don't want to have to save around and have 7,000 15 years from now. How much can I pay you each year so that I own it at the end? Kind of like a reverse mortgage.
Okay.
It's a little bit like a reverse mortgage. So this is an FA problem.
An F8 problem?
FA or AF. You're given F and you want to find A. So in this case, you're given F and you want to find A. It's this guy. So this is that's the problem 3 to use.
Did that one right?
Okay. And now, what's the present value of problem 3? So now that you know A, that becomes an AP problem. All right, problem 5 takes a little more thought. So it's kind of two problems in one. So mechanical device will cost 20,000 when purchased. It's the present value. Maintenance will cost 1,000 each year. That's your annuity cost. The device will generate 5,000 each year. That's also your annuity. At the end of 5 years, the salvage value is expected to be 7,000. That's the future value. So it says, what is the net present value of this proposal using 8.3? Let's take a look and see what we came up with. I think I solved this thing. Let's just take a look. Okay, 20,000 when purchased. Yeah, so here's the mechanism cost, and I'm asking how much it costs right now. So that's like term 0. So these numbers kind of become irrelevant. They can just kind of nuke those out of there. That's one way to do it here. No fill. So, and even the F and P don't really mean much because we're just saying, what's the thing cost now? What's going to cost me $20,000? Maintenance will be 1,000 each year. So that's another cost. And I'm working problem number 5. And we're going to do this over 5 years. So again, 20,000 cost, 1,000 cost. And so we know that the present value, we're going to use the annuity, which is, the annuity in this case is a cost. That's why it's negative 1,000. I'm not making this, I'm spending it, just like I spent that 20,000. So I'll use that same exact formula, the A to P, and come up with the fact that, yeah, that's basically, 3,961 in today's dollars at 8.3%. Let's see if that's the case. 8.3%, yep. So these guys we can just kind of get rid of too. And for me, I'm like, well, let's just leave it in its original location. Get rid of some of this extraneous text. The device will generate 5,000 each year. Now, in that case, I know that I'm going to make 5K. I've got that same 8.3%. So that's the same as having $19,000 now, because I could have taken my money and invested it at 8.3%, and that's kind of what I'm assuming here. So you always have to have a 2. Well, that's one thing I didn't say about the grading. Every spreadsheet has to have the number 2 in cell K11.
Why?
Just kidding.
What did I miss?
That's the secret of this course. Unless you have the number 2 in Caleb. Like, what is that 2 doing? Oh yeah, it's the secret 2. Never mind. He's lost his mind. He's lost it. So, again, 20,000 expense up front, 1,000 in maintenance. So I've, there's the mechanical cost, materials cost, mechanical cost, whatever you call it, maintenance cost, and here's your revenue, because you've got a power purchase agreement with the utility. And, yeah. So you could either have $5,000 a year for 5 years, or since money is, it's kind of weird. I don't want to say worth more because it's actually worth less. Money is always becoming worth less. That's why it's called the discount value. Because it's going to take more dollars in the future to equal the same number of dollars as in the present.
Yeah.
Candy bars don't cost a nickel anymore. Gas doesn't cost a quarter a gallon anymore. Like, there's this balloon of money, always, well, that's why somebody call it the bubble popped, right? So, okay. Let's go ahead and delete this too. And then the final part, it says, at the end of 5 years, the salvage value is expected to be $7,000. So it's going to be $7,000 in the future. What is it worth in the present? So $7,000 in the future. What's it worth in the present? Done that already. Yeah. So it's worth. And this is again, the first time you see this, like, that cannot be right.
I know.
It's just like, that cannot be right. The thing cannot be worth more. But the thing is, it's like, what's this piece of junk worth now versus what's the piece of junk worth in the future? You might think, well, okay, so I don't know. I'm not really sure how to think about that, but it could just.
Well, you're not going to use a gaming system there. You're not going to buy a PS4 this year for the same price that you're going to pay for it next year.
Right.
It's going to decrease in value by that next year.
It will.
Why? Because there's a newer model made coming out.
Yeah. The problem I always have my head wrapping around, that's how much it's going to be worth in 5 years. That's how much it's worth now, which is actually less. So I keep thinking that should be, but I guess the point is the $7,000 scrap in the future. Well, you just know it's going to be worth $7,000 in scrap in the future. I could either
Save it.
yeah, I can, and if I want to buy it in the future, I better take my $4,698 and invest it at 8.3%, and then I'll have enough money to buy it in the future. Okay. So we've kind of got all 4 portions of the problem worked out. What is the net present value of this proposal using 8.3%? Now, that's the that's the answer I come up with. because you had to spend the 20,000, you had to spend the 1,000, you're making 5, and at the end you're making 7. So it's worth something, but not much.
Let's see. You just added them all together?
I just added them all, oh yeah, I just added them together.
The -20, the -1,000,
Yep. Yep,
or the -3, whatever?
yep.
Okay. Okay. That makes it easy.
Mm-hmm. Now, we could also do something a little fancier. Try not to mess this up, but if we, let's just say we do this and say term. I'll put it in years. I'll put the number 5 in here. I'll say this equals that. So I'm just going to change it a little bit at a time. Nothing changed, right? That number stayed the same. And I'll say this number equals that. 19,000, that's the same. And I'll say this number equals, again, 5. So I'm doing the entire problem right here. Just going to squish those cells down. If I run it longer, I'm going to make more money. If I run it longer, because remember, my income is 5,000 a year, and my maintenance is only 1,000. So the longer I run it,
More.
yeah. Now, in general, so I'll run it for 20 years. Okay, great, I'm making a lot more money. Now, unfortunately, I'm not sure I know how to.
You can control Z out.
You can also grab them all and make them the same height. Did you see that? Yeah. Okay, so now I think it might be also kind of fun to do something like this. Take this and just kind of line them up. See, I'm just dragging them over there. Now it's just all in one.
I have OCD, I move it in that way.
Yeah, yeah. Now another thing we could do, this might be kind of fun. Just drag them even closer. I'm just going to show you this as a little trick. This idea just came to me. This is not part of the homework, but this is the power. This is part of the power of Excel. This whole drag deal. As if I have what I'm going to do, if I put this as, I'm going to take this, drag it down here, 20, insert, I'm just kind of having fun with it now. If you need to go, it's totally fine. I'm gonna take this, copy it, paste it. But I'm also going to, I'm gonna pin the value at B.
Lock its domain in.
I am. I'm gonna pin the 9.
Don't you put $2 in there though, between the letter and the number?
No, so I don't need, I just need the number to float, so I'll do this. So now I can take this and just drag it out, so if I want to do it for 5 different numbers,
Oh,
or 4 different, it's all the same. Right, so I did the same problem over and over again. Now for maintenance, I'll do the same thing. Dollars per year, so that's gonna be $B. I'm gonna keep the, this is a little bit redundant because I'm gonna use that 8% each time. I really might just do that one discount rate for the whole problem.
okay, I'm following you.
Yeah. I'm gonna do that. And you'll notice I'm just pinning this one and this one,
Right, but not the term.
not the terms. I want to make it a function of the term. So, that's fine. I think you get the gist of it.
Well, no, that helped.
Yeah. Yeah.
I tried to have that assignment done.
Well, I
Try.
hope Lacey feels better, sure. So none of these numbers are changing, that's good. I don't want them to. Put in $B, $B. And now I'm going to type in 5. I'm going to type in 10. I'm going to type in 15. I'm going to type in 20.
Oh, hi.
Yeah, and so now I'm going to take each of these other guys. I've copied that one. I'm going to drag it over for. I'm going to say this equals 10.
And then you should be able to drag that.
I can just drag that across too, can't I?
Should be able to, yep.
Yep. And then do the same thing here.
I don't need the other.
Not a problem. I'll see you.
See you in 2 days.
Just having so much fun. Yeah. And then we'll just look at your course lists. If you drop something by.
Yeah, I have my geothermal course and my other solar.
Oh, that's because there's still people finishing them. And I wish I could just remove them for you, but I can't do it on a student by student basis.
That's all right.
If there's a way for you to hide it, great. If not, sorry. Well, I know.
Wow.
Okay.
See you someday.
See ya. So in this guy, and then I'll just say this equals, again, 10. And again, I can drag that. And here, I'll take this, drag it, and I'll say this equals that. Drag this, and now I can take this, drag it. Oh, I need to go over there. Yeah, just 1 second. Almost, okay. Drag that, and now I should be able to come in here and plot this. So I can see that in 5 years, if I run the thing for 5 years, it's worth $500 now. If I run it for 10, it's worth 10,000, 15. So it's, roughly $1,000 a year for every year I run it, roughly. If I run it for 5, though, I don't make my money back as quickly. And the chances of my maintenance only being 1,000 a year is probably not that great. But let's do insert chart. All charts. Let's do one of these guys. You can play around with that, but yeah. So 20 years, it's going to be worth more. So there you go. Just kind of something to think about, something to play with. We will be building functions like this as we get a little further in the course. So hopefully that gave you a sense of what we're up to, and see you next week.